also on behalf of the co-conveners, Dr. Vaishali, Dr. Monali, Dr. Revati, and Dr. Vishwanathan, who have taken great efforts to organize this symposium. And I understand that this is the first in-house symposium that we are having in the School of Engineering here at the Dayanand Sagar University. So it's a very nice moment to have such a wonderful event. And the idea of this symposium came during very casual and informal discussions Dr. Srinivas and I had. And hello? So Dr. Srinivas and I were having formal, very informal exchanges in a casual chat when the idea of this in-house symposium came up, and Dr. Srinivas led this whole operation with tremendous energy, and his experience in managing everything over here was very impressive, and I really enjoyed working with him on this project. And it's a great delight and a great honor to be a part of this exercise, because the in-house symposium is an opportunity for our faculty members to present their research work, and something that we discovered with great joy, that a lot of faculty members over here are doing excellent research work over here. It's absolutely top of the line work, and there is so much to present, so much to show. And it is important that our best practices receive sufficient visibility, and these are put out as our regular activities. So we thought that we will use this opportunity to have this in-house symposium. We met the Vice Chancellor, and Dr. K.N.B. Murthy was extremely supportive of this idea. He gave us very positive inputs and also guidance in making the arrangements. He also kindly agreed to give his time and deliver the inaugural address. So we met him some time back, Dr. Srinivas and I. So this has really been a wonderful teamwork by everybody under the leadership of Dr. K.N.B. Murthy and Dr. A. Srinivas. So this is a time of global collaboration. We live in a connected world, and so many new things are happening. We recently heard a very nice symposium of which Dr. Viraj was a major part of, which was on the national education policy. And we also learned that one of the things that is going to happen under the national education policy, Dr. Viraj is of course with us, so he can correct me or elaborate further. But we learned that many foreign universities will also begin to make their presence felt in India. And we are going to be living in a very competitive world. So I think it's very important that the Dayanand Sagar University emerges as one of the best players at the very forefront of creation and dissemination of knowledge. So amongst various criteria which are used to assess a university's importance, I think the contribution to frontier science, innovations, pushing the frontiers in terms of research publications, patents, and so on. These are great parameters. So let me find out if Dr. Murthy is available. He sent me a message a little while ago that he has back-to-back meetings today. So let me check if he is available, and if he's available, we will request him to deliver the inaugural address. Otherwise, he asked me to move on with the event. So let me first find out if he's available. Can somebody tell me if he's available? Has he been able to join the Zoom meeting?
We see, not here, not here. Okay. I don't think he was able to join because he had expressed his difficulties in view of his preoccupations. I think we should
Yes.
carry on.
Okay, so we will do that. In case he's able to join a little bit later, we will certainly invite him to deliver the inaugural address. In the meantime, we will move on with the next event that is scheduled, which is a very fascinating event. This is the keynote address by Dr. Viraj Kumar and Dr. Rajani. And they're going to talk about something which is, I think, awesome. They will be presenting us their studies on an area which seems to integrate history, archaeology, astronomy, mathematics, geometry, whatnot, and then using modern imaging techniques and frontier research in computer science. They will be telling us about some of their research which they have carried out. So we have, I believe, Dr. Surya Narayana with us, who I will request. Has Dr. Surya Narayana joined? Is he around?
Let me call him, sir. Just give me 1 second.
Yes, Dr. Surya is there. I saw.
Is
Just
he
one
there?
minute. Yeah, he has joined. I have spoken to
Yeah,
him.
so is his mic unmuted? So
I will just
yeah.
Not. It is. I think it's muted.
mute it. Okay, no problem. No problem. Just give me a minute.
So he might have thought that there's going to be a 10, 20 minutes talk by the Vice
Can you?
Chancellor.
Hello.
Dr. Surya, can you just send a chat box message if you are able to unmute?
No, I think he has been joined as a co-host. He should be able to speak.
Yes.
I guess.
Yes, I think now I am unmuted. I can
Yes,
speak.
yes.
Yeah, so Dr. Suryanarayana, it is wonderful to have you at this meeting, and we are looking forward to a very exciting talk by Dr. Viraj Kumar and Dr. Rajani. And both are known to all of us at the Dayanand Sagar University very well. But nonetheless, it will be wonderful if Dr. Suryanarayana will introduce them to the gathering here. So Dr. Surya, may I request you to please introduce Dr. Rajani and Dr. Viraj Kumar?
Yes, sir. Thank you very much. And it's my privilege to introduce the keynote speakers for the occasion today. And I would like to thank Professor Deshmukh for creating this kind of a forum where we could freely interact and discuss with each other on kind of research topics we have been engaged in. And this is certainly educative and also interactive. And I would like to thank him for having initiated this kind of activity. So let me first start with Dr. Rajani, who works in the area of, in multidisciplinary areas. And she has been the associate professor at the NIAS, at the National Institute of Advanced Studies. And her research interests are in landscape archaeology and geospatial analysis of cultural heritage. And truly, it's a multidisciplinary activity. And recently, she has published a book on patterns in past settlements, geospatial analysis of imprints of cultural heritage of landscapes, published by Springer. I'm not sure if it's already published or it may be in the publishing line. Okay, and she is an elected member of the Indian National Young Academy of Sciences from during the period 2018-22, and she's a young affiliate with 2019-2023 of the World Academy of Sciences, and she is a recipient of P.R. Pisharodi Memorial Award 2019, given by the Indian Society of Remote Sensing. And she has also been speaking on about her research in various TEDx forums. Welcome to Dr. Rajani. Then we have Dr. Viraj Kumar, who is a research professor in the Department of Computer Science and Engineering at our university. His primary research interests are in educational technology and computer science education. And prior to joining DSU, he was a visiting professor at IIC during 2018 to 20, when he continues to teach there for undergrads in computer science courses. He was invited to serve on two task groups of Karnataka Knowledge Commission in 2014 and 16. And he has also served as a consultant to the National New Academy Educational Policy constituted in 2017. And since 2015, he has been an active contributor to the ACM India, and he was also elected to the ACM Council India in 2020. So I would like to extend welcome to Dr. Veeresh Kumar, and I request them to start the keynote address. Thank you.
Thank you. Thank you very much. Thank you very much for this opportunity for us to present this work we did as collaborators. This work actually springs from one of my earlier work where I worked on the landscape of Nalanda University. Yeah. So on the left, there is this map of a planimetric map of top-down view of Nalanda University or Nalanda Mahavihara. This is known to be the oldest university, or rather a Buddhist monastery, which attracted monks from very far region. The famous one being Fahian and Xuanzang from China. And it is known to have had thousands, some records says 3,000, some records says 10,000 people living there at a time. The site itself, or the establishment itself, the earliest records go back to 4th, 5th century, and is known to have existed till about late 12th and early 13th century. However, it obviously was not in the same stage all throughout. It probably started in a small size, grew, and maybe deteriorated, and so on. But today, what we have as excavated site on ground is this area. The area marked in yellow boundary is the area protected by Archaeological Survey of India. And the structures marked in red are the sacred structures, which are called chaityas. And the structures marked in blue are monastic structures. Those were the place where the monks lived. It had rooms on the edges, whereas the central hall was the place where they gathered for their discussions and so on. So my preliminary work was actually looking around this area to see if there are more telltale signs of how big the site was. Because for a long time, it is believed that the actual Nalanda was much bigger than what we protect today. This itself is about 1 kilometer north-south and another kilometer east-west. So it is believed, and it is now confirmed, that the site was at least 5 kilometers north-south, extended 5 kilometers north-south. But within this excavated area, we noticed a pattern of orientation of its structures. By orientation, I mean on the right, we have a dial, and this arrow is pointing at an angle. So by orientation, all the numbers here we are talking about are the azimuth numbers, that is the angle of its center axis compared to the true north. So for all these 6 sacred structures, we have such angles: 94, 95, 96, 99, 98, and so on. So we found they all are east-facing structures. So we began to wonder, why are they 94, 95, and not 90? Because we wondered whether they were trying to face east, because it is a regular practice for temple and sacred structures to face east. Even today, temples are built to face east. So, but why is it 94 and plus rather than 90? Because 90 would have been true east. The first thought was whether they went wrong. They were actually trying to get true east, but they went wrong by 4 meters. So 4 degrees. So this led us to start questioning how this was happening. First, before we go into our exploration of this orientation, I want to just introduce how these structures look. This is the oldest of the structure called T3, Temple 3. These numbers are based on the sequence when they were excavated. And this is how it looks. And Temple 3 is believed to have built in several phases. At least 7 phases they have found. And here we can see at least 3 phases. So, and it is believed that the earlier phase is inside the later phase, and it's like Russian dolls. And this is how Temple 3 looked. The top left picture shows how it looked when it was first discovered. And the left lower one and the top right one are at various stages of its conservation. And the top right lower one is how it looks today. And here is a photo to show that as part of its conservation in the last 150 years, bricks of the size and shape of the original bricks were made and replaced. So if today I wanted to date this structure, I may have technology to date bricks. But if I go to the site, I may not find an authentic old brick because quite a lot of it has been added as part of conservation of the site. Here is the second structure, Temple 12. This is how it looks on ground. Here is Temple 13, and this is how it looks on ground when you look at it from east, the way it faces. Here is Temple 14. Here is Temple 2. Not much of its superstructure remains. So it's mainly its plinth. And here is the structure which is called Sarai Temple. So these are the 6 sacred structures in the site. So when we went back trying to look at how temples were oriented at the time, we found determining the cardinal direction was one of the prerequisites for constructing temples in ancient India. And there were 2 types of orientation methods. One was through observing fixed stars, and one was through observing gnomon shadows. So we'll come to each one of them. The Indian circle method is through gnomon shadows, was first mentioned in Katyayana Sulva Shastra, which goes back several centuries BC. And Al-Biruni gave this method the name, the Indian circle method. And this method is by planting a stake in the center and drawing a circle around it of the same radius as the stake, and observing the shadow of the stake entering the circle and exiting the circle on either side of noon, and then joining these 2 points, and that point becomes east-west line. So here is another picture showing the same thing. So Brahmagupta, who lived in the 7th century, identified that this method had an error of maximum 0.5 degree. Maximum because if this observation of shadow was done closer to equinox, the error was 0.5 degree. And if it was done closer to solstice, there was no error. So he had at 7th century identified that the maximum error by this method could be 0.5 degree. So then we realized that if the builders of Nalanda were aiming at east, when they already would have had a method that could give an measurement of error up to 5 degrees, they couldn't have gone wrong by 4 degrees because all the measurements we have are more than 4 degrees. So we realized that they were looking at something else. And I also want to mention Sripati actually gave a correction for this 0.5 degree error in 12th century. So there was a lot of interest in geometry and accuracy. So 4 degree was not an error. They were actually aiming at something else. So then we wondered what were they aiming at, whether they were aiming at rising of sun on a particular day, like in the example of some temples in Southeast Asia. It has been suggested that when sun rises, a stake is planted and the shadow is taken as a baseline and the rest of the temple is drawn around it. And this is based on a whole lot of temples built decades across, facing, or rather oriented towards the in the angles, that is the range of solar rise across the year. The range at Nalanda is very narrow. They are all very close to each other, just half degree or a degree at the most from each other, but there is slight differences in each of them. We looked at whether they fit into any of the major solar cycle events like equinox or solstice. They don't. The angles rapidly change at sunrise closer to equinox. And if it is a cloudy day, hazy day, and all that, they wouldn't have been able to stick to a particular date. So that also is not possible. Then we questioned whether it could be moon. Moon has complex phases, hard to get a one-point shadow. And there are important dates in lunar cycle also, major standstill, minor standstill. Those angles are very far from the angles that we are looking at. So we thought moon also was not a target. Then we thought whether its star could be a target used by other ancient structures. Like, for instance, it has been proposed that the pyramids in Egypt was aligned to stars. And these two structures in Rhamnos, Greece, is believed to have been aligned with stars. And there is a slight tilt between these structures. And it's also believed this tilt also explains both the structures being aligned to the same star, and the position of the star has changed over time. So then we thought, using a star as our hypothesis, we could explain this 5 degree of variation in the because of axial precession. So axial precession is the precession that the Earth's axis goes through over a long period of time. It takes about 25,000 years for it to go a whole circle. So what we notice as pole star today, that is our axis, Earth's axis on the north points towards pole star today or now. If after we have passed some 12,000 years, it would be pointing at Vega. And then when we complete our cycle of 25,000 years, it will come back and point at pole star. So it goes through this precession like how a top goes through when it is rotating. So then we try to see if what was the status of astronomy in India at the time these sites were active. Aryabhatta I, who lived in 5th, 6th century, is known to have practiced astronomy at Kusumapura or Pataliputra, the capital of Gupta Empire, identified with today's Patna. Nalanda is not far from Patna. It is claimed that Aryabhatta headed an institution or observatory at Nalanda, where astronomy was an important field of study. But we don't have further evidence for that. So to understand what will be the implications for an observer on Earth, implication of axial precession for an observer on Earth, I try to simulate this using stellarium. Here I have given a date of -1000, early morning, because most observations were done just before sunrise. Early morning, eastern horizon at Nalanda's latitude. So here, just to guide our eyes, I'm putting some constellation markings and also marking of ecliptic and equator. Now keep your eyes on this particular star, which is Spica, known as Chitra in Sanskrit. And here are its metadata about its angle, azimuth, declination, and so on. So in -1000, it was north of east. And in 0, it had moved south of east. And for every 1000 years, if you had observed from the same point, the same star, over 25,000 years, the star would move like this. Okay. So using this, this is the effect of axial precession for an observer on ground from the same location at the same height from ground, height of the star from ground. Now, what do we know of dates for the existing sites, structures of Nalanda? We don't know much. We only know some relative dates, that one structure was built after another structure and so on. The excavation that was done there haven't been able to produce confident dates. So then we thought we have to look at other contemporary sites to get some corroboration, because if we want to date a particular site using a star, if we have some other corroboration, it would be helpful. So sacred structures, we looked at sacred structures from sites where there is evidence for interaction with Nalanda, structures whose construction is sufficiently exposed. Therefore, we ignore unexcavated structures. You saw, I showed you a picture of how that excavated structure now looked originally. So if we had only found a mount, we wouldn't have been able to measure its orientation. So we needed structures that were exposed sufficiently. Structures whose central construction are symmetrically straddled. So we needed at least 2 east-west lines, which could be measured, and average of it could be taken. Some structures we could only get 1 line on one side. Then we didn't feel confident that we had got the angle, the central axis of it. Because when they would have laid out the plan for constructing that, they would have started with a central east-west line and then built the rest. But we are not able to see the central east-west line. So we try to take 2 lines, one on north and one on south, and take the measure them and take the average of them. Structures whose orientation deviate from the cardinal direction in a similar manner that Nalanda structure deviated. So here are 2 structures at Vikramshila and Somapura. These both were built by the king Dharmapala of Pala dynasty and Pala period. And these monasteries, this is sacred structure in the monasteries of Vikramshila and Somapura. They were contemporary with Nalanda in the latter half. So they were active between 8th century and 12th century. And they also have the same sort of rotation or tilt as this Nalanda structures. So this is the picture of their overall quadrangle. The central structure is the sacred structure. Here is a picture of Vikramshila. Somapura is in Bangladesh, so I haven't been able to visit Somapura, but Vikramshila is in eastern Bihar, which I have visited. Bodh Gaya also has a similar tilt like the others. And here is Samye. Samye is the first monastery in Tibet, first Buddhist monastery in Tibet, and Samye's construction was based on one of the Pala dynasty, the first Pala dynasty monastery called Odantapuri, which we don't.
Are you trying to contact me?
Sorry. Okay, so Samye,
okay.
which is in Tibet currently.
Yeah. Okay. I'm listening.
Okay.
I'm online right now. Yeah. Okay.
Okay. So we have some dates for the 4 I just now introduced: Bodh Gaya, Vikramshila, Somapura, and Samye. So, but with Bodh Gaya also, we don't have very confident dates. So the only ones left were Vikramshila, Somapura, and Samye. So now to look at which were the target star for them to orient their structures, I went back to around 400 AD in Stellarium. I set the date as 400 AD. And then I tried to see that across the year in 400 AD, what all stars would rise around this point, which is around 94 degrees. So I went through the whole year and found that one of the belt stars of Orion, which is about to rise soon, yeah, one of the belt stars of Orion, and one star in the constellation of Hydra, this one, and then the star Spica, Chitra, and Beta Librae all rise around 94 degree in 400 AD. These 4 stars. So what's interesting about these are some of them rose in the same place in 400 AD, but as we go to 1200 AD, which is the other extreme of Nalanda's activity, their angles shift. One of them are going upward, the others are going downward, and only Spica and Beta Librae actually occupy this range of 5 degree of variations in the structure's orientation at Nalanda. So let us take Spica first. Spica was just south of east in 400 AD, and by 800 AD it had moved 2 degrees, and by 1200 AD it had moved 2 more, 2.5 and 2.5 actually. And Spica was very close to the intersection between ecliptic and equator in the early centuries of this millennia. And the other star we are looking at is Vishaka, which was not very far from Spica. And Vishaka also moved, but it moved about 2 degrees and 2 more degrees. So the range of Vishaka was slightly less. So between Vishaka and Spica, we were looking at one versus the other. Vishaka or Beta Librae was Buddha's birth star. So we thought whether that would make it special enough for orient all the structures. Whereas Spica is much brighter, Vishaka is much dimmer. It may not have been visible also when it is very low. And Spica was close to the intersection of ecliptic and equator at the time of the early temples. So here comes whether astronomy was the reason or whether religion was the reason for this orienting the temples. Or it may even have been religion, and Spica, because it was brighter, was used as a proxy. So as we can see, Spica is very close to this intersection of ecliptic and equator. So Spica probably behaved as like how pole star marks one north, Spica probably marked one side of the cosmic globe. I'll request Vikram to Viraj to take over.
Okay, so we don't have very much evidence for the fact that in fact these methods were used to orient these temples, right? This is just a hypothesis, right? And one of the things we don't have access to is, what technology could they have used, right? Earlier on, Rajni spoke about if you wanted to measure, align to the rise of the sun, there were these different, the method of sticking a stake. So we are just hypothesizing here that, trying to figure out the angle at which a particular star rises doesn't require a great deal of technology. Once again, you could put a stake over at one end, the eastern end of the site, and then hold a plumb line and just try and align that to the star as it rises. So that's what the picture on the left is showing. Well, the top picture is showing. The bottom picture is the same thing, but I want to point out something very important, right? So the difference in the diagram on the top and the diagram on the bottom is, in the diagram on the bottom, there is some sort of hillock, right? Some hill, some occlusion in the east. And you notice that these stars, you saw them in the simulation that Rajni was showing from Stellarium, they don't rise straight up, right? They rise at an angle. Right? So if they're trying to orient a temple towards the rise of a star, and that star rises at an angle, then that angle will be a little bit larger if you have to wait for the star to clear a hill or clear an occlusion, right? So we're going to come back to this very important point in a little while. So I just wanted to share this picture with everybody that, if you are trying to measure the angle at which a star is rising and the ground is flat, you will get one angle. But if you have to wait for the star to rise beyond a certain height before you can see it, then you will actually get a slightly larger angle. So that's what these two pictures are showing. Okay, so here is what we did to actually measure these temples, because we think they are oriented towards the rise of one of those two stars. So firstly, we looked at the image that had the least parallax. So we tried to find images that were most vertical, right? Then we tried to find images where we can see these east-west walls, right? And we measured the average, as Rajni was saying. So here, for example, this is a Bikramshila. So we, as Rajni was saying, it's probably some central line was laid out, but now there's a structure sitting on top of that, so we don't have access to that. So we assume that the average of the northern wall and the southern wall is a good approximation to the true orientation, right? That's what we did. We were looking for these kinds of pairs of lines, and we didn't find them at all sites, but at most of the sites we were able to find this. So these angles we measured, relative to north, and then took the average of those two. So here is what we are trying to do. So this is perhaps, the big results that we were trying to get, right? So on this graph, I have on the vertical axis, the y-axis, I have the angle at which these 4 stars that we were considering, what is the angle at which they are rising when you wait for them to rise to a 3 degrees altitude above the horizon. And on the x-axis, I have the year, right? So this is that full 26,000 year cycle that Rajni was talking about. And you see that each of these angles, they change and they go through this full cycle, right? They started around 94 or whatever, and they go the full cycle, right? So what we can do, of course, we can think of this, as the azimuth z, the angle z, as a function of the year, right? And the details of the function depends on which star. So that's the different colored lines, and which latitude you're at. So we have temples. Some of them are at Nalanda, some of them are at Samye. There's a big difference in latitude over there. And this altitude, which for now we have just assumed as 3 degrees, and later on I'll tell you a little bit about why we assumed it as 3 degrees. So this is what this picture is trying to say. Now here is the big insight, right? So remember, we are hypothesizing, we are guessing that the temple was oriented towards a star. Now we know a lot about where the star was over this 26,000 year period, right? So if that orientation was exact, then by measuring the orientation of the temple, assuming that that was pointing exactly to where the star was, we can date the temple, right? So if you remember, Rajni was saying how difficult it is to otherwise get dates. There's very little historical record. You cannot even do very much carbon dating on some of the material. It's difficult to have access to it, and then there are other problems with it. So this is an independent and rather novel way of dating a temple, assuming that they were pointing to a particular star, and they did a good job of orienting it to that star. So there are a few assumptions in here, but if we make those assumptions, then we're actually able to date. So this was the thing that we were aiming for, and then we said, okay, how much can we gain from this hypothesis, right? So we'll focus on just, this is a 26,000 year period. We're just interested in this period where Nalanda was, so we can zoom in on that. And there actually these functions are essentially straight lines, right? So Professor Deshmukh, you mentioned at the start that we had this may also have used cutting edge computing. Actually, it only used just linear regression because the functions were so straightforward, right? But because it's easy to invert these functions, so we can focus on these. And as Rajni was saying, only 2 of them really sort of fit our range of angles. So here they are. So in blue there's Spica, and in red there's Beta Librae or Vishaka. So these were the 2 that we were looking at, right? So we just did this calculation, right? So we just, as I said, did this linear regression, and we came up with these functions. So for each latitude, for each site, we were able to come up with a different linear model. And so we could calculate the angle Z, and just by applying this simple formula, we could, from that, we could figure out the year Y, right? And all this is assuming that there are no errors, but of course there can be errors, on all kinds of errors, right? So if you introduce an error term, then you get a corresponding error in the year. So basically, if we are saying that the angle that we are observing for the structure is some Z, but then the true angle, that they were trying to aim at, meaning the angle at which the star was actually rising, was not exactly Z, it was maybe Z plus minus E, then for us to try and take the measured Z and figure out a year ends up giving us an error in the year also, because we have to account for the error in Z, right? So that's all this is trying to say. It's the only equations we have in the paper. Okay, so what are some of these errors? Well, when they were building the temple, right, they had to measure this angle of the star. There could have been error in that. We know very little about that because we really, there's just a guess that they were even doing this, and so we don't know anything about what method they actually used, whether it was that plumb line or whatever it was, right? And then the exact altitude at which they measured the star, we don't know for sure. Again, there are some assumptions over there. Right? Then, of course, they would have put that line, let's say, and maybe there's a slight error there, but then they have to build a temple on top of that. So by the time the temple is built, which is what we are actually measuring, there may have been errors in that, right? So all that is errors baked in long before Rajni and I came on the scene. And then we are trying to measure, so there are errors in our measurement, exactly, we're sort of visualizing by eye, trying to figure out where these lines are. And then we're relying on, the Stellarium model. And Stellarium's models themselves also are iteratively refined. And so over a period of time, there can be differences in the model. So there can be errors due to that as well. So there are many sources of error, and we don't know what each of these are. So all we can do, the best we can do, is make some assumptions about the cumulative effect of all these errors. And our results are in terms of, if we assume that the error is so much, then we can say something, right? So that is what it is. Right? Now, I want to talk a little bit about how we got to that 3 degrees altitude, right? So Rajni mentioned that, for 3 of these sites, we have decent dates, right? But very unfortunately, for 2 of these sites, these angles that we are getting are a little bit off, right? So we have some problems over here. So let's firstly try and understand why that is happening, because these orientations are about 1.4 degrees higher than our linear model is suggesting, right? So it turns out that for both sites, we have a common explanation. So we're at least a little bit confident that we have understood why we are seeing this extra 1.4 degrees. So if you look at Vikramshila, the picture on the ground is the bottom is at ground level, and you can see that slight hill on the right, And the picture on top, is a digital elevation model where the red colors mean higher, right? So if you look at that outline of Vikramshila on the left, and you're looking at this line going towards the east, you can see that it's pointing towards these red marks. So there is some occlusion over there. And remember, I told you that if there's an occlusion, then you have to, wait for the star to rise above that hill, and that might explain why we're seeing it's more of an angle. If you remember the angle at which the star was rising, that could explain it. The second explanation, the second site is Samye, and this is in Tibet. And if you look at that site again, you can see that if you're looking at in that direction, in the far distance there are some hills, right? In fact, some pretty big mountains. Interestingly, if you think about where the site is located, imagine if you had so north is to the left, okay? So we're looking towards the east, so north is to the left. So imagine they had actually located the site a little bit further north, then of course they would have had even more occlusion by these big mountains. And if they try to go a little bit further south, there's that other hill that starts coming in the foreground, right? It's a smaller one, but that would start impeding them. So actually, when we looked at this, of course, we were disappointed that, there were all these occlusions. We can't help it. Those mountains are there. But in some sense, it gave us confidence that we're looking at the right thing, because, in some sense, we can see, oh, they were trying to find some sort of local optimum over here to trying to locate the site where there was least occlusion in the direction in which they were interested. Right? So again, this is a little bit after the fact spinning the story, but at least it's as I said, it makes us feel that we have a reason for why the numbers are a little bit higher for Samye. So that only leaves this one site, and that is Somapura, and there we have some very good evidence. So there's some seals that have been found over there at the site that connect it to Dharmapala, and we know dates for Dharmapala. So we have this rather narrow 50-year range. I mean, we're talking about thousands of years, so 50-year range is a very good range for us to be able to date this particular structure. Right? So it's good enough for us. So then what we did is we said, okay, assuming that there was this technique and they were trying to look at a particular star, Could it have been Spica? Could it have been Beta Librae, right? And if at what altitude were they trying to measure it? And basically, what this table shows is that if you look at 3 degrees altitude, then it fits the date range for all reasonable errors that we might imagine. So on the leftmost column are all the possible errors, the cumulative error we might have. And you notice that as the error increases, the date range in the main table becomes wider and wider and wider. But the point I want you to note is that for 3 degrees altitude for Spica and for 4 degrees altitude for Beta Librae, these numbers work well. So what we're saying eventually is that we think that it was either Spica measured at 3 degrees altitude or Beta Librae measured at 4 degrees altitude, because those seem to fit the data. We only have this one solid data point, right? But now that we have made that guess, now that we have sort of grounded our model with that data point, we can now go back and apply our linear models. These are the actual equations, and apply our linear models and come up with these date ranges. So on the x-axis are increasingly the cumulative error. So all the way on the left is 0 degrees, and all the way on the right is 0.5 degrees, right? And as the error becomes larger and larger and larger, for each temple, the date range becomes wider and wider and wider. So we end up with these cones. I mean, if we assume 0 degree error, we have an exact date at which the temple was created. So on the y-axis is the year in which the temple was created. And as the assumed error becomes larger and larger, our estimate becomes fuzzier and fuzzier. We start losing precision on exactly when this temple was created. But this is what we can say, with some confidence. Now, if we assume that the error is not too much, then this result tells us something new about the dates in which, the time in which these temples were created. So this is essentially the novel contribution of this paper. There are many ifs in this, if this hypothesis is true. So each of these, like all science, is falsifiable. Subsequent investigations may find that, in fact, there is, some fact which completely is contrary to the hypothesis. That's fine. But our paper has been published, because thus far there is no other competing hypothesis that gives us this level of dates for these sites, this level of precision. So that's our talk, and we'll be really, really happy to take questions. I hope we didn't exceed the time.
Well, thank you very much. This has been such a fascinating talk. It's really very interesting that you were able to use the precision of the Earth's axis and do this very interesting calculation. The simplicity that you claim in the calculation about the linear relationship is, I think, only in the geometry and the arithmetic, but not in the idea which you have used. I think it's an amazing idea. I'm sure there are some very exciting questions. I noticed that Dr. Radhika has a question. So Radhika, would you like to ask it yourself? Radhika? She has posted her question in the chat box and I can read it out. Radhika, are you there?
She may not be able to unmute herself.
Yes, so let me read out Radhika's question. She is concerned that all astronomers may not agree with this, and her argument is that stars are fixed at their positions and the Earth is rotating, and every 6 months there will be a change in the alignment. So her question is, are the different errors estimated at 3 sigma or 5 sigma? That's her question.
Okay, so we don't know enough about most of these things to make any further claims about the error. So all of these are assumed errors, assumed cumulative errors, right? So actually we have absolutely no idea about the magnitudes of these. So our entire result is, if the cumulative error is this much, then we can say something about it. So we're, you know, apart from the measures that the measurements that we ourselves have made, right, you know, which, as I said, is an eye estimation. We don't have, I mean, that is probably the only one for which we could have, you know, answered her question, but eventually that is only one of many errors. So we actually didn't, you know, end up computing something like that.
The other thing about astronomers not agreeing, we were very conscious of it because neither of us are astronomers. And we have been working on this. I mean, we started this somewhere in 2014 or so. And we have colleagues in Indian Institute of Astrophysics and Raman Research Institute, who we were regularly consulting whether we can use Stellarium as a software for these measurements, or would they suggest something better? And we presented that this is what we are getting for multiple astronomers. And in fact, Indian Institute of Astrophysics was one of the first places we presented this talk as well. So, and we made sure that astronomers don't have a problem with it before we went ahead for publication.
Thank you very much. There is another question here. If Stellarium is licensed or is it free?
It's free. I mean, I don't know whether there is a pro version also, but for whatever for whatever we required it, that is to give a particular date and know the location. That version is free, and again they keep giving updated versions. And again, we also consulted astronomers for because they keep updating these versions. How long will these measurements be okay? So then they told us in the date range we are looking at, that is 2,000 years maximum or 1,500 maximum behind from now. They said it's not going to significantly change, as we found as well. So in the duration that we were working, there were 3 or 4 updates. And only place where I found problem was when I was making that graph of 25,000 years. So 25,000 years from now, the measurements were slightly changing, but not, 1,500 range.
And Dr. Surya Narayana has a question. Dr. Surya has a question. He's asking if there is any ground evidence which supports your conclusion. So I don't know what is suggested by ground evidence, but perhaps you can respond to it.
Okay.
So we could do ground measurements, and for certain sites, if we wanted to extend this, so I mentioned that we are able to for our measurements, we're looking at this top-down satellite view and then measuring these walls. There are many interesting sites that are contemporaneous with Nalanda, but then the structures are circular. Rajni, did you want to speak about those?
Even again, in our paper, we discuss this, and sometimes when we have a 1-hour talk or more, we discuss it in some more detail. Even for the sites that we have consulted. In fact, this whole study started because one mentor of mine was studying temples at Nalanda, and he was trying to measure these orientation on ground, and he found it is very challenging, because if you take some instrument and put it, because individual bricks may be slightly tilted, and it was giving different measurements for him. So he came to me asking whether there was a method, because on ground I find there are too many challenges, whether with satellite images you have a way to get a more reliable line across the whole structure rather than going on ground. So some sites have this problem of the individual bricks. Some sites like Bodh Gaya, it's a lived-in, active, worshipped site where there are lots of decorations, flowers, and ancillary structures and other activities happening. And forget about regulation, even then to get a straight line of 40-50 meters becomes a challenge. And even for these sites, we find measuring with satellite imagery was much better and easier and more, we could get more confident results than from measuring on ground. And yes, we had to exclude many structures which may have been also using this method somehow, because their architectural style didn't reveal straight lines for us to measure.
Do you suspect that during these 1300 years there could have been some major earthquakes or anything of this kind which might have changed the mountain structure and the reference points that you have used, because that area has been prone to such events?
Yes, that area is very active. In fact, probably Samye actually falls north of Brahmaputra, and it's a different continent, in the whole continental plates shift and things like that. So we recognize that. Only we feel our initial data points were all from one complex, that is 6 buildings from Nalanda's complex. So though I feel that between different sites, these changes could happen, I don't think the relative angles within this complex could have been affected by either continental shift or by earthquake related shift.
Yeah, that's interesting. Dr. Sanjay Chitnis has a comment. I do not know if he can unmute himself and say it himself. Sanjay, can you?
Yeah, I could unmute myself, so that's good.
Oh, great.
So
Yes.
I think first of all, it's very excellent research, especially the interdisciplinary nature of that, and yeah, quite exciting. We can keep on thinking and talking for a long time. So I was just trying to fit this as a machine learning problem, because you did mention that, right? You're trying to find the function f, right? And that's what is basically machine learning. Here you have hypothesized that it's they're trying to align with a particular star, but probably that may not be required to even hypothesize that, because basically machine learning is fitting into existing data. Of course, we have to check in terms of different parameters for that, right? Like, for example, you mentioned if there is a hill, then they are looking at different times and different natures, etc. Even what Professor Adhika mentioned, that season based itself, right? The part of the year there will be some kind of movement of the same star, from northeast to southeast kind of thing. So all those parameters can be put in, and then we can try to find the function f. And once we find the function f, then we can try to relate it with the physical reality, like what that function means on the ground, right? So that could be another approach. But this is, of course, very, very basic, just random thought. I'm sure both of you have given a lot of thought and effort. I know a lot of things you have consulted. So, but just I thought it may be worthwhile to make such a random comment.
Yeah. So certainly there can be other explanations, right, for the for the data that we're observing. So this is one possibility. There could be other hypotheses.
Yeah, I just wanted to come back to that point about season and star. The star rising time will change in annual, at different dates or months, but the star rising angle won't change so fast across within a year. So that is not affected by season. It might rise today at 5 o'clock and tomorrow at 4 minutes minus 5 o'clock. But and therefore by next month it will rise an hour earlier or whatever. But the angle won't change within a year. It will change very slowly, and that's what we are using to state here.
Okay, thanks. Got it. Yeah, true.
Yeah, I mean this precision angle would change about a degree over something like human lifetime over 70, 80 years,
72 years.
Yeah, 72 years.
Something years.
So it's not going to change a whole lot. Yes.
Therefore, if we didn't, if they attempted orienting today and there was cloud and there was rain and it was not visible, even if they waited for a whole month, they could still do it.
Yes. Dr. Surya has a further comment question with reference to his previous question. He was asking about the ground evidence kind of thing. And what he clarifies that he is referring to any archaeological surveys to validate your theory based on some known data, especially since there are lots of archaeological sites in India.
Yeah. Well, this whole inquiry started because Nalanda as a site was first excavated in 1861 by the founding director of Archaeological Survey of India, Cunningham. And after that, there have been many excavations, last being 1983-84. And with all the work they have done, they haven't been able to conclusively, strongly date those structures. And we are still finding alternative ways of dating those structures. So at Nalanda, and out of the work that is already done by archaeologists, we don't have dates. And this is a sort of alternative way of producing those dates. There are complications. The early excavations at Nalanda were not properly documented. Lots of material were removed. They are there in Calcutta Museum, Bihar Museum, in Nalanda Museum, sometimes abroad museums and so on. But we don't know exactly which building they were picked up from because they were not documented properly. And therefore, dating some object that is in museum today using modern techniques like maybe AMS dating, OSL and so on, will not provide us a date for a particular structure because we are not able to associate. We don't have the provenance of where these things come from. That is one complication. Now there are structures on the site. If we want to go and collect mortar, which can be dated easily, or brick also, which can be dated depending on the carbon available in it. So if we want to collect it, as I already showed with some pictures, that since 1861, apart from clearing vegetation and dust for the site, in order to beautify, because it was a very British concept to beautify a site, to make it like to showcase it for visitors and things like that. In order to beautify it, a lot of surface material has been replaced. Though the Gupta brick size and Pala brick size have a specific size and shape, modern bricks were made in order to put them and make it look new and neat and so on. So it is, apart from the regulatory hurdles, it's a challenge to identify an authentic old brick from the site. So all these are existing archaeological questions as far as Nalanda is concerned.
Is there any other comment? I think Vinayak has commented that if wood is used, it is the best way to measure the age of the structure. And that,
yes, unfortunately, we don't have wooden samples excavated from Nalanda.
Yeah, all right. Well, a very fascinating talk. So astronomy is always inspiring. Means it really, in many ways, it is the mother of many sciences and mathematics and so on. And so much of science and mathematics comes out of it. It is, it's a wonderful integration of modern techniques that you have used to solve a very interesting question. I totally agree with your conclusion that yes, there are sources of errors, there are some assumptions which have been made, and it will be very hard to claim that this is completely accurate. Nonetheless, I think it is an extremely important study. There is no question about it, because it lays down a method which is very likely to be correct, and certainly further corrections and improvisations can be attempted on that. But I think it's a great start. And as Dr. Viraj pointed out, this was the first study of this kind. So considering that, I think I would like to congratulate both of you for a wonderful piece of work. Thank you very much for sharing it with us.
Yeah. Can
We
I
missed.
just,
Yes, please.
sorry to interrupt.
Not at all.
I just wanted to mention that there is a expert, especially on Nalanda from Minnesota University, Frederick Asher, who's been working on the site for 30, 40 years. He, when we met in a conference and we discussed, he was the one who first said, will you be able to, I have tried measuring orientation on ground, but can you measure on the image? And I have a feeling, he said, I have a feeling that they can be grouped into two sets. And with that, he said, maybe one set is Gupta period structures and another set is Pala period structures, because this is how the range of dates fall. So I said, I can try measuring. And when I measured, I found all were different. And I said, no, there is something else happening. So he was the first one we were presenting it for. So he's a sort of authority as far as known possibilities are concerned. So our research curiosity springs from a conversation with him. And he's been our sort of reviewer also for this work.
Yeah, sure. There are these. That's the nice thing about doing research. When you talk to colleagues and friends, and sometimes in very casual conversation, new ideas come out, and they lead to some brilliant piece of work. And to that effect, I think this idea of having an in-house symposium, which Dr. Srinivas triggered in our very casual conversation, I think it will go a very long way. And I'm sure it will be nice to hear Dr. Srinivas comment on the symposium and other things. We also have the possibility of having the Vice Chancellor's inaugural address. So let me first go to Dr. Srinivas and request him to make a few comments, and then we will try to find out once again if the Vice Chancellor has been able to join. So, Dr. Srinivas? Hello? Dr. Srinivas? Vaishali, can you reach out to him? I don't know if he's able to hear me.
Yeah, I will.
Yeah, so if you can find out if Dr. Srinivas is available, he might.
Yeah, sure. Just give me 1 minute.
Sure. So our co-conveners, Vaishali, Monali, Revati, and Vishwanathan have done a great job in coordinating this symposium. So, and thanks also to Mr. Imtiaz, who has provided the technology support, which makes all of us possible to meet on this platform. So thank you, Imtiaz.
Okay, I think Dean sir is in some meeting. He sent a message to me.
Yes.
Yes, so he's not here.
Yeah, I have a suspicion that he is in the same meeting in which the Vice Chancellor is engaged. And that probably suggests that neither of them is available immediately. So we are going to have a tiny little break. What time does the next session begin, Vaishali?
The next session's
It will start at
timing is
3:30.
3:30. Yes.
It will start at 3:30. So we were we'll have about a little over 15 minutes break, and then we will reassemble for the next session. So we're going to have some very nice sessions. The next session will be on development of devices for applications in science. And then tomorrow we have a session on material research, and then advances in interdisciplinary areas. Then there will be a session on wireless networks and sensors. And we will also have a student session tomorrow evening toward the end of the day. So I think this is a very nice effort by all of our, the whole school has participated in this and coming up with this program. And faculty and students have joined. The students will also be making some presentations. There are well over 125, 120, 130 participants in this. And I assume that there may be more who would have joined on the YouTube. I do not have that number at the moment, but I'm sure the symposium is being telecast live on the YouTube, so there may be some attendees there. So thank you all very much, and we will resume for the next session at 3:30. Thank you very much, Dr. Biraj and Dr. Rajani. Thank you very much for a brilliant contribution.
Thank you.
All right, thank you. So we'll meet in about 15-20 minutes. Vaishali?
Yes, yes.
You want to make any announcement?
Okay, the next session is so after 15 minutes, start our first session. Yeah, that will be chaired by Dr. Sanjay Chitnis. So so sir is also here. So after 15 minutes of break, we all will gather here once again to have the talks of 3 speakers in that session.
Yes.
Looking forward for that one. Yeah.
And Sanjay will chair that session. So thank you, Sanjay, and thanks to everybody.
Yeah, sure, sir. So see you all at 3:25.
Yes.
Thanks.
Sure.